Get it back.
Looking for your party.
Yes, sir. Thank you. Yes, sir.
Good for the night. I do actually, I don't know everything. Oh, buddy, that happens to go though, it's the money. No, because I have a tour, I'm sorry. I didn't mean to say, I didn't mean to turn out, sorry, I'm sorry.
Okay, let's start this class. Yeah. Everyone. Yeah, let's take.
1, 2, 3, all.
Yeah. Okay, let's start this class. Today we will do a class review. Yeah, because we have already finished all the labs we need to finish, and only the final project we left. Yeah, firstly, we will talk about like class review, and then we will talk about the final project a little bit. Yeah, because I don't know. Yeah, let's start. Yeah, okay. Firstly, let's do a course overview. Yeah, we know. Yeah, after this semester, we firstly we try to introduce the Pico, Pico to you, and different parts have different function, and which parts mainly focus on which function like that. And then, yeah, after this course, and how to do a MicroPython programming. Am I right? Actually, yeah, I think the MicroPython programming actually is very similar with Python programming. Yeah, and after this class, and I think you can do the programming for other class. Yeah, for example, robotic 1, 2, yeah. And then hands-on labs almost each week. Yeah, you can see every week you have the new labs, and then try to build the circuit, try to write down the code and make the like a code and the hardware work together and implement some specific function. Yeah, and then we implement some real world applications. For example, the robot, for example, the read sensor data, and then try to control something. Yeah. And this is what we have already learned in this class. And let's review the labs we have already finished one by one, and then do a summary. Yeah. The first one, yeah, we just try to do an introduction, and then we learn the MicroPython. I know like some students don't have much experience on programming. I think Ben, yeah, you told me you doesn't have, yeah. But after this class, I think at least a little. Yeah, you know how to debug. You know how to find the problems. Yeah, when you meet some bugs like that. Yeah. Okay, and this is just like the first one. Yeah, we just try to do an introduction and just try to learn how to use MicroPython to control the Pico. And we try to blinking the LED light. And actually, yeah, after this lab, I noticed some students just don't have much experience on programming. So you give me some ideas next spring, and I will give students the MicroPython programming materials first before the semester. Yeah, let them to familiar with that part. I think that will be better. Okay, and lab 2, yeah, we focus on the GPIO pin functionality. Yeah, actually, after we finish all the labs in this semester, you will find mostly we use different pins and consider different pins as output, input, and then read some data, and then deal with those data and output something. Yeah, the GPIO actually is very important for us in this class because the input output is very important for the microcontroller. And you can see how to deal with it, how to deal with the data. It's just a code part. Am I right? Yeah. you just write specific code and then implement a specific function. But the input output is very important. Yeah, like I said, the microcontroller has very important three parts: the input, the processing, and the output. Yeah, that make do you remember? Yeah, when we talk about that. Yeah, so for these labs, we mainly focus on like blinking LED with button, the LED control with the PWM, and the pin like etiquette. Like after you finish your lab, after you do a specific task, you need to quit different pins. Yeah, like release different pins. Yeah, it's very important. Yeah, I don't know if you remember, if you didn't release it, and even after you stop your code, and you can see your LED maybe still on. Yeah, and yeah, it's very important. And also like we learn the PWM here, and we know like the PWM has different very important features. Like you can try to adjust the PWM based on two different parameters. Do you remember what are those two? Do you remember? For the PWM? If you want to adjust the PWM, there are very important two parameters, variables. Do you remember? Yeah, if you want to adjust the PWM, what you will adjust? Huh? Yeah, frequency. Yeah, frequency. And what's the other one? Yeah, duty cycle. Yeah. Actually, you can see when we try to use PWM to control the LED, the duty control what? Like the duty. Yeah, that's right. Yeah, it actually, if you like observe it, it will just affect the brightness. Yeah, because the duty cycle will affect the power. Yeah, do you remember? Yes. Yeah. And okay, this is lab 2. And lab 3 is a bit crunching. Yeah, actually for the bit crunching, does anyone remember anything about the lab 3?
Yeah, you press buttons and you put in binary inputs and then output a digital.
Yeah. Actually, we use two different ways to like put input binary and then output like voltage like change. Yeah, ADC like that. Do you remember which what are those two methods? Do you remember?
What was the question?
Actually, yeah. Actually, for this lab, like we need to like implement build some binary number. Am I right?
Yeah.
Yeah, and we use two different methods to build those binary number.
Oh yeah, it was the methods where you had like a voltmeter and you would change it and it would input a different binary value on there, and you had the button so you put in binary number.
Yeah, but I think this is not that lab. Yeah, this is the lab 4.
Oh.
Yeah, this one is just we try to build some binary number.
I don't remember.
And does anyone know that? Yeah, we try to use two different methods to build the binary number. What are those two different methods? Do you remember? Yeah, what?
We like that two button.
Yeah.
Click the one.
Yeah.
Is that lab 1?
I thought that was just said.
Oh, you just said that?
Yeah, I said the two buttons.
Oh, I said you said potential meter.
Yeah. As well. I think that's another one as well.
Oh yeah. Okay. Sorry, I didn't get the I just got the potential meter, so I think that's the other one. Yeah. You know, like the binary number is 0101. I'm right. Like the off on. I'm right. So like we have two buttons, and click it means 1. Like not click means 0. I'm right. So we just build two like bit binary number. I'm right. If we want to build a 3-bit, what did you do? Do you remember? What did you do? Yeah, actually, like you just said, we just use two button, am I right, to build a 2-bit binary number, am I right? If we want to build a 3-bit like binary number, what should you do?
Put another button in there.
Yeah, put another button, am I right? And this is the first method. What's the second method? Do you remember? Yeah, there should be 2 buttons and one forward, one forward.
Oh.
Yeah. Yeah, one for what?
One was to change the first value from 0 to 1.
Yeah.
And the second value was like if you wanted to increase the bits, you would like hold it and it would go to the next one. Next thing over, and then you can you input another 0 or 1.
Oh, okay. One is for clock. I think you know that, but you don't know the name for that. You know, you just got that point. One is for the clock, the other for the date read. The clock, which means every time when I press it and release it, I read the data. And the read data, if I press it, it means 1. I didn't press it, it means 0, which means I can read the data like any bits I want, like not only 1 bit, not only 2 bits, not only 3 bits. I can read as many bits as I can. That makes sense to you? Yeah. So actually, this one is just like very important because it's the basic thing, how the microcontroller, how the data process in the microcontroller, in the CPU, in the computer. Yeah, because it will use the clock signals to read the data, and also we will use like the binary number, yeah, to deal with we will like deal with binary number in the computer, in the microcontroller, in the microprocessor. Yeah, now the analog signals, now the decimal numbers, the binary number. Yeah. Okay, any question so far? Okay. And then yeah, we learn this one. Yeah, we try to use potentiometer, yeah, to make like a multimeter and to adjust the potentiometer and adjust the voltage, and then try to read the voltage using the pico. Yeah, because the voltage will stand for some specific binary number. Yeah, for different width, it has different corresponding number. For the 8-bit ADC. 8-bit ADC, what does that mean? Any question? Any other students? All students? 8-bit ADC, what does that mean? Huh? Yeah. 8-bit and the 16-bit, what's the difference? Yeah. Yeah, there is a 8-bit ADC and the 16-bit ADC. What's the difference? Yeah, accuracy. Yeah, which means the 8-bit ADC, the maximum number will be 255. I'm right, 0 to 255, which means it will divide 3.3 volt like into 256 unit. And yeah, you just try to read the pico W value and then try to calculate the voltage based on that. That makes sense to you? And the 16-bit, which means your range should be from 0 to 65,300, blah, 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 like that. Which means you just divide your voltage into 65,000 unit, which means your process will be, you have more procession. That makes sense to you? Any question? Yeah. This is just like how to do analog, how to convert analog to digital. Because you can see the pico here, it only can deal with digital signal, am I right? Yeah, we talk about that. The pico only can deal with the digital signal because why? Because what? Because it's a pin only read high or low. I'm right. 3.3 or 0 like that. Yeah, but the outside environment, the voltage, the sensor, any other things, it will give us a continuous voltage. I'm right. So we need to deal with this continuous voltage. Yeah, so that's the reason why we need analog to digital converter. That makes sense to you? Yeah, and actually you will use this in the other project, maybe in other class, but you need to know that. Okay, and the lab 5 discharging capacitor. Actually, you can see from lab 1 to lab 4, it's a kind of fundamental lab. It will tell you what's the most important part for the Pico, the output, input, the microprocessor, and how the Pico W work. It only reads high and low, am I right? It can read the analog signals, but you need to convert the analog to digital firstly, and then the microcontroller will deal with it. But since from lab 5, it kind of like a application. Yeah, it not only focus on the basic fundamental function for the Pico W, it just tell us like what the Pico W will do. Yeah, you can see the lab 5, which means we can use the Pico W to observe the capacities function. Am I right? So actually, we just use onboard like a 16-bit ADC as a digital voltmeter to measurement the capacitor discharge. Am I right? Yeah, do you remember? Yeah, we just try to use Pico to read the discharge voltage during this time, and then try to draw the line. Do you remember? Yeah, and which means we can use Pico W to observe different circuit, different components, feature, the characters. Am I right? Yeah, that makes sense to you? Yeah, so here we just try to observe the capacitor discharger. But you can imagine, yeah, we can also use Pico W to observe other components like feature or capacity characters. For example, the amplifier. Yeah, like we will learn it in microelectronics. Or some like inductor or resistor or some other circuit, RC circuit or some other circuit. You can use Pico W to read the voltage, am I right? To try to analyze this data. That makes sense to you? Yeah, this is just an example. This is just a specific lab. And then for the lab 6, and do you remember we try to use different resistor. Here is a photoresistor. Yeah, do you remember? Like it can detect the light. Yeah, and also the thermistor. Yeah, like this one can detect the water temperature. Yeah, do you remember? Yeah, which means our Pico can use sensors to sense the environment around it and read the data and analyze the data. Yeah, do you remember? Any other question? Okay, and then the lab 7. Yeah, the lab 7, actually, do you remember what lab 7 do? Actually, this one is also very important. Yeah. Yeah, we will use the TLC. Yeah. Yeah, let me ask you one question. What is SPI? Sensory peripheral interface. What's that? Yeah. It's a proto like that. It just give you some way to talk with other devices or other companies. What else? What else proto the Pico have? Do you remember what else protos the Pico have? Yeah. Yeah. You also have the other two, but we didn't talk about them here. But I give you the homework. Actually, they just two other different protos, and which means it just use different method to talk with the other devices. It depends on the situation you use Pico, and it depends on what devices you use to communicate with Pico. Yeah, if you for the final project, maybe you will use the other like portals, yeah, to communicate with to communicate with the other devices. Actually, you can see for these SPI portals, yeah, they will they provide clock signals, CS clock and input output. I'm right? Do you remember? Yeah, which means it will generate clock signals automatically. I'm right? It will yeah. That makes sense to you? Any questions? Yeah. And then it will, if you give the clock and give you CS, and it will, and then these portals can help you to communicate with other devices. That makes sense to you? Yeah. So this one is also very important because it's very, it's also a basic thing for the Pico W, and which means you can use some specific method to communicate with the devices. You can see for this, oh, here for this one, we just try to build the clock signal by ourselves. Am I right? We try to use code and just like make this pin high, low, high, and it's a one clock. But here we don't need to build our own like clock signal. It will generate the like automatically signals. That makes sense to you? Yeah, clock signals. You just set the frequency or for these clock signals. That makes sense to you? Yeah, and then for the lab 8, actually, this one, we just also read some sensors. Do you remember this one? We just drop the French. Yeah, and it will try to evaluate the gravity accelerator like that. That makes sense to you? And we just use also the Pico. We will read for the Pico. The Pico will read the data, and then we analyze this data and try to calculate the gravity accelerator. Yeah, and the lab 8, lab 9, actually it's the other application. We just use the Sonic Ranger to measurement the distance Pico with the other device like object. Yeah, do you remember? Yeah, those are all like some applications the Pico can do. Like, oh, I just use Pico and I just use some sensors to measurement the environment around me and read something. Yeah, but from lab 5 to lab like 9, actually we just use the input. I'm right. We use the input to read the data, but we didn't use the output. Actually, it's just a part of microcontroller. There's a microcontroller, which means we read the data and we need to do an output to control something. Am I right? But for the lab 5 to lab 9, we just read data. Am I right? We try to deal with this data, but we didn't do an output. We didn't try to control something. Am I right? Yeah. And then for the lab 10, then we try to use the POW to control. Yeah, which means we just try to use the output to control the like motor's speed. Yeah, we try to use there is a PWM signals, and we try to use the PWM signals to control the speed of the motor. Yeah, do you remember? Yeah, and the 11 also. Yeah, we try to use the H bridge and try to control the motor's speed and the direction. Yeah, this is just kind of control. Yeah, and then let's okay, and then the take home lab, which means we use the web server to control this motor. Yeah, to do like a speed control and the directions control. Am I right? So let's do a summary. Actually, for the microcontroller, yeah, you can see it mainly focuses on 3 different parts: the input, the microprocessor, and the output. Which means we just try to use the input to read data, am I right? To read to sense the environment, to read the data, and then we try to use the microprocessor to deal with this data, to analyze this data, to calculate this data, and then we try to use the output to control the devices, control those things. Yeah, actually, I want to ask you a very important question. For the final project, what's your input? What's your output? What's your control?
For us, our input is button,
Yeah.
and then our output is our message is on LCD.
Yeah. That's great. Yeah. So for the Dylan's group, you know you mainly focus on the people with eye impairment, which means you give it a sound. I'm right. You give the person a sound. But did you consider like how can you verify the people get your message? Yeah, he will hit the button. I'm right. Yeah. So you need to like make this whole process to like after the people hit the button and then it just give I know that I'm right. Yeah, just make it a whole loop. Yeah, not only like the I just give the user a message, but I don't know if it receive or not. I'm right. If these people receive or not. Yeah. So you need to like try to consider that. Yeah, that makes sense to you. Yeah, this is just a whole loop, the microcontrollers loop like that. Okay, and then what have we built? Actually, you can see from step by step. Firstly, we just try to know what's the GPIO, what can GPIO do, and then we try to familiar with what is ADC and how the PQW deal with the data get from the sensor. I'm right. Yeah, it just like try to convert the analog signal to a digital signal and then deal with the digital signal. I'm right. And then timing, yeah, for the DC RC charger and the capacitor charger and many other things, you can see you just use timing to get the data. Am I right? Do you remember your code? Like you just try to do a while and get the data in timing. Save it to like a file and then try to analyze it. And for the sensor, you just try to get data from the sensor. I'm right. And lastly, you just try to control the motor and like finally you will try to do a system integration. Yeah, our final project you will see. Actually, you can see your like a different group have different in different points. But you can see for the Dylan just said, after the people receive the message and people will do a click, am right? And then if his hands not very stable, what should we do? And then the John's team group will resolve that problem. That makes sense to you? And yeah, so you can see your four teams should be work together to resolve one problem like that. Yeah, it's just a kind of system integration. Yeah. Okay. Any other question? Any questions for now? Okay. And then actually for this class, I think you should like master these skills, and I think you have already mastered these skills. Firstly, you learned how to control outputs. Yeah, you can see for our master. I'm right. Yeah, maybe learn. Yeah. Okay. Okay, and then like as we know, like during our labs, we know how to control LED. Am I right? How to control motors, and you can try to imagine not only LED and motors you can control. You can control anything. Actually, you can control a people. Am I right? Yeah, for the final project, you can control these people with dimension. Am I right? And for some system, you can control the air condition. And you can control the anything you want. I'm right. Through a system you build. That makes sense to you? Yeah. Okay. And then you learn how to sense inputs. Yeah. For during our labs, you can see sometimes you just read data from buttons. You just read data from ADC sensors and temperature sensors, ultrasonic sensors. But not only those sensors. Yeah, actually you can read any sensors you can. Am I right? Yeah, just buy some specific sensors and read the data from using the PQW or other devices. Okay, so which means after this class, you need to learn how to control outputs and how to sense the inputs. Yeah, have you? Do you know how to? For now, did you? No? Did you? No? Do you know how to like sense control the outputs and how to source the inputs for now?
Yes.
Yeah, I think you know that, right? Okay, and then we just like you need to know how to do timing and the processing. Yeah, you can see during our lab you do a RC discharging timing, ultrasonic echo timing, and pulse wise measurement. I'm right. So you use the pico W to do a timing and to do a calculation. I'm right. This relates to the timing and processing. So after, yeah, you can see not only for this kind of physical like quantities. If you want to measurement other things, you can use the same method. That makes sense here. Yes. And the other one is PWM and power control. Yeah, you can see you can use PWM to control the LED brightness and the motor speed. And you but not only for the motor, not only for the LED, you can control anything. I'm right. Yeah. After this class, what we learn in this class is just to teach you the method. I'm right. Let you know how to do that. But if I change the device, if I change the task goal, you need to know how to do that. That makes sense to you? Yeah. Okay. And then the system thinking, you can see, you just try, you not only like implement one single function, am I right? You try to use the whole system to do a distance meter, a motor controller, and a robotic subsystem. Yeah, because like the small robot dual means it's just a kind of subsystem for robot, am I right? So you know that it's kind of a system, am I right? Yeah. So you can see, I think every students do in those kind of like labs, you just like go through this kind of process. Yeah, you build this system, you build this lab, and then you test it, and you will find there are something wrong. You cannot run it, and you find it, you fail it, but then you debug it. You will try to find the problems, where are the problems are, and how to resolve it. And then after that, you improve it and continue. This is a loop. And actually, this is what you need to learn in this class. Am I right? Yeah. The specific thing you learn in this class, actually, it's important, but it's not the point. You need to learn how, not what. Not only what. Yeah, that makes sense to you? Yeah. Okay. So there is one sentence you can see the debugging is engineering. Yeah, I think most of them are engineer, right? So you need to know how to debug your system, how to debug your code, how to debug your circuit. Yeah, this is the most important thing for you. Any question? Okay. And then, yeah, for now, like we learn some labs, am I right? Those labs actually, it's not complicated. It's quite, yeah, but this is the first step for you. Yeah, you can see after this course, you can try to do like a home automation systems, and you can implement a robot like a navigation, obstacle avoidance. Yeah, and you can also do environment monitoring, like temperature, distance measurement. And also the digital voltmeters and sensor data logging, and the customer electrics and photo taps. Yeah, you should do those kind of tasks after this class. Yeah, that makes sense to you? Yeah. So, like I said, what you learned is not important, and the most important is how you finish this task. Am I right? Yeah. If you know how, and then you just do a successful job in this class. Yeah, that makes sense to you? Okay, any questions for this class? Okay, and for the final project, yeah, and I noticed you didn't, some of you didn't submit the weekly report. Yeah, the weekly report is very important because it can help me to know like what's your process, and help you to try to figure out what you should do and what have you finished, what haven't you finished. Yeah, so you need to do that. And the documentation, like a I think there is one person to charge the like a documentation, right? So you need to focus on that. Yeah, like give me the weekly report. Yeah, the weekly report will take part some grading, take part the final project grading. Okay, and for the final project presentation, which day do you think is a perfect day for you? Yeah, you know it is will be the next week, right? Like let me show it for you. Yeah. So for the next week, you just try to focus on the final project. And yeah, this is okay. This week. And okay, the next week, you just focus on final project. And the next week, and we will have a presentation during these 4 days, am I right? Like final what?
What day is our final?
Yeah, so I'm discussing this one with you.
Yeah, but schedule final.
Oh, schedule final. I think it's just a regular, like from Monday to Tuesday, am I right?
No.
What?
We have like a scheduled final time.
Uh-huh.
but it's
Okay.
Not actually classes that week.
Okay, let me open that for you.
Because we gotta make sure our phone doesn't conflict with the others.
Final.
Time slot is from 8 to 10. Oh, shit.
Okay, yeah, this one.
4 PM Monday through 7.
Yeah.
So. Our slot is the 4 to 6 on the 27th. Yeah, so that's when. Damn, that's earlier, get used to that.
Yeah,
All the engineering classes.
this one, right? This part, this during this time, right?
Yeah.
That's scheduled expensive.
Yeah.
No, I thought it's 8 to 10 a.m.
No, that's for Monday, Wednesday, Friday.
Yeah, that's what, we're just Monday, Wednesday, don't do
This is Monday.
Oh,
Monday,
okay,
Wednesday,
okay.
That's confusing.
I think,
Look at the ones next one.
okay, in my opinion, I think we can choose
Oh.
here.
This is not.
No, it's, okay, look, at the bottom it says Monday, Wednesday, or Monday, Wednesday, Friday. We are a Monday, Wednesday class, so we are at 4 to 6.
Yeah, so
Oh,
Monday.
Starting time, our starting time is at 10 a.m.
Yes.
10 a.m. There's no Monday, Wednesday. So it's Monday, so it's gotta be Wednesday.
They just forgot about it.
Yeah, they just forgot about.
So,
So it's gotta be Monday, maybe.
Don't fucking wait, bro.
I think we should do 4 to 6, we're gonna do on Monday.
I think we can do Monday or Wednesday, am I right?
I have.
No?
on Wednesday, so.
No, we don't really. No, we have it next week.
Okay, so you think Monday will be the perfect time?
Monday.
We have to.
Monday or Wednesday?
Yeah.
Huh? Monday, 1 PM? Everyone agree that?
Hold on, Monday at 1?
Monday 1?
Wait, where we? Okay.
You need to think, yeah, that's the point.
Still finals then.
Wait, no finals at 1.
There's no finals at 1.
There's no final.
Yeah, so Monday 1?
Monday at 1, that works.
Monday 1?
Wednesday have a big.
Yeah. What?
Thursday from like
2 or 4?
I mean,
2, 3, 4?
yeah, 2, 4.
I have 1. Yeah.
What do you have at 11 o'clock? Huh? What's your response? Oh, it's the count. Everyone has the finals like they're.
Yeah, you're usually rich, you know, 10 days.
It's all.
Wait, 8 a.m.?
8 AM?
No. Oh, it's a line one.
So why don't we do 4 to 6 on Monday?
4 to 6, is that okay?
Yeah, sorry, 4? Yeah, it works.
Start 4? 4? 4?
Yeah.
Okay,
Yeah. I'll put it down.
yeah. Monday 4 to, Monday 4, is that okay?
Yes.
Okay, Monday 4. Yeah, everyone agree that, Anna?
So it's Saturday.
Saturday?
Yeah, there's no.
Okay.
He hasn't class before, but
Yeah,
because of our last, Oh, your jeans.
okay, let's decide Monday 4, am I right?
Yes.
Okay, Monday 4, okay. Okay, and you have 8 minutes to discuss final. And yeah, any questions? Any other questions? Any questions so far? Okay. And honey, you know you need to make up several labs.
Yeah.
Okay. Do I need to send an email to you? Which one? Okay. Okay.
I'll bring mine.
Yes.
So.
Yeah, I know, I'm a little
I'm
bit.
still gonna. We should take.
Give them, make a schedule.
Yeah, we have a schedule.
Oh, yeah.
Yeah, we already had that. We had that planned out since, like last week. We just changed it up, they changed it up a little bit last week, so we have a new schedule now. So, I'll just go.
I saw the post on Instagram, I saw Greg there. I've been planning on. Two 15 PM is going. Oh, thanks, son. I'm at a music recital. 3:25.
Yeah.
Yeah, look at my concert. Wait, oh, it's you go to, okay. Yeah, it's just one. Why? Yes, it's $9.